Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're going to see problem number 3 and 4 of today's bi-weekly contest. Find the maximum length of good subsequence 1 and subsequence 2. Both are same, just the constraint difference. But before that, we have a aim before June 45k subs. Let's see if we can do it. I hope we can. Yeah, let's start off. Now, just a big disclaimer or a big, you can say hint. If you want to not spoil the problem, you can just skip it. But for the folks, I highly recommend 1, 2, 3. I'm going to tell you should have watched LIS problem again, the basic one, n square one. Why it is used, how it to think of when it should be used. If you want to know that, go and watch this video. Now let's come on back. So you are given an integer array nums where there is a non-negative integer k and a sequence of integer sequences is good if there are at most k indices I. In the range 0 to this sequence such that this is not equal. I'll tell you in a simple language. It says that you are given an integer array called as nums. You have a k value. This is nums. You have to grab a sequence, or you can say a subsequence out of this entire nums such that whatsoever sequence you have got, if I take the consecutive element in that sequence which you have formed, the number of, and if they are different, as you can see 1 and 2, they are coming adjacent and they are different. Okay. 2 and 1, they are coming adjacent, they are different. So these number of such difference can be at max 2, which is k. That's your problem. Now, very basic brute force thing which can come to our mind is Aryan generate all the possible subsequences and then find which is the longest subsequence which follow this specific pattern. Now, if we go on and generate all the subsequences itself, it will take a 2h power n time that will give us TLE. Now, we know in these kind of problems, when I have option for every number to take, not take, I know again, it is a subsequence. Subsequence is made if you have an option, take, not take. So I can simply ask my DP because I know I have watched this video. Now, I know, okay, it can be a DP. It looks like I have some subsequence and I want to maximize the length of that subsequence based on a different condition, which is k in this case. Now, in a standard such kind of problems, we take a random index I. Now, I know it is same as that of my LIS. In LIS, what I do, I go on to all the previous indexes. If that index j value, which is nums of j, if it is less than my nums of I can increase the length. But in our case, what I can say, okay, I am still at I will go and try for all the possible previous j's, but now I want to maximize my length. I want to increase my length. To increase my length, I know one thing. In general case, I can take any number. There is nothing like that. Okay, I can take 2 also. I can take 1 also. I can take 1 also. I can take anything. So you might say, Aryan, which means that, okay, my DP of I value is nothing but DP of I existing. I want to maximize my DP value. So it will be DP of j, all the previous j plus 1. But no, there's one condition, which is that you have to keep in consideration your k. So what I can do, okay, I can go and jump onto a previous value. If it is different, then I'm using one of my k's. So here my k, one of my k is reduced. So I can only jump on here if I have some remaining k left. So what I realized is I want to basically have my index I, but I will go and try for all the possible j's. But I know if my nums of I, if it is not equals to my nums of j, then I know one thing for sure, my remaining k will decrease by 1 because I'm actually going on to an element which is not equal to me. If it would have been equal, which means nums of I is equal to my nums of j, then I can just simply go on to that value and can simply take in consideration my remaining k will remain as it is. If I would have jumped on to the 1 only, so my remaining k would have remained as it is because I don't need to spend any k because it is the same value. So that's how we realized how we can simply write the exact same code, just tweaking the little bit code for our LIS problem. Cool. Let's see the code. It's pretty simple. It's just that we are going to previous index. Now, previous index, I just have one more variable, which is k, which means remaining k for my case. So firstly, I will initialize my DP value. I know again, usually you can write the solve function by yourself. So solve function will look something like this, that okay, I am at a specific index and this is my remaining k, what I can do. So what I will do, I will try to maximize my length. I will go on to all the previous j's. If my nums of I is equal to nums of j, I know I can simply go on to that j and I don't need to decrease my remaining k. It can remain as it is. But if it is not equal, then I can go to j and I have to reduce my remaining k by 1. Although you can put this condition of remaining k more than equal to 0, more than 0, you can put it as a base condition also, but I just put it here only, that I can go on to my previous j. I know that it is not equal, so I have to decrease my remaining k. So I should make sure remaining k should be more than 0. Only then I can afford to decrease it. And I know as I'm going on to previous j, so basically I am incorporating current I and previous j. Previous j answer this will give me. Current is I. I'm basically adding one more number, like one more number. So plus 1 for that. Same way, plus 1 for that. Now, this is a simple recursive condition. I know how to simply memorize it. To memorize it, I can simply take my dp of I and remaining k, and I'll simply take dp of I and remaining k and just simply memorizing my maximum length, and thus getting maximum length as an answer. Now, the base case, it does not affect because how I've written the actual case of calling it. So what I've done is I've initialized my dp. I know I have to initialize my dp by I and k. Now, the problem statement itself says, again, this is for the medium one, which is subsequence 1. So it simply says that your I, which means your n, can be 500 and your k can be minimum of 500 or 25, which means n or 25. N can be 10 also, that's the reason. So I have done the same thing, that n and 25. Again, plus 1 for safety. Now I have got the maximum length. I have called my recursive function solve starting from this index I, whatsoever is the, again, ending at that index I, what's the maximum subsequence length I can get, considering I can afford at max k differences. You remember what's the differences? That nums of I is not nums of j. That many maximum I can afford, ending at that index I, give me the maximum answer. Then I will just maximize the maximum length. And that's how I can simply return the maximum length. Now you might ask, Aryan, this complexity wise, this solve function will take O of n into k time. N for I and k for remaining k. Okay. Then this loop will again take O of n time. Okay. So technically your solve function itself is taking a O of n square into k time. But then you are calling the solve function from your again one for loop. So Aryan, are you saying it is n cube into k? No. Why no? Because here I am calling for all the possible i's, which means if I am calling for a specific I, it will, this memoization will make sure that if I have already something for that I will simply return it, which means I will go on to a specific I and k pair only once. That's the reason I will visit combinedly for all the for loops. I will ask the solve function only for O of n square into k time. That's it. Cool. Now, that's the reason that the time for me is O of n square into k. The space, as I have simply used a O of n and k space, so my space is O of n into k. Now, if I just see with the medium problem, it is the constraints given. N is 500, k is 25. So if I just ask and if I just tell you, okay, time will be O of n square into k. N square into k, it will be roughly around 2 into 1/6, which will work. But if I apply the same code for a hard problem, here in the hard problem, the constraints are a bit different. N is 5,000, k is 50. So if I just apply the same thing, it will be around 1e9. Again, less than it, but roughly touching 1e8 to 1e9, which is not okay. Now, I have to optimize it. How should I optimize it? Firstly, let's see what was the bottleneck. What is something which is the bottleneck here, which is actually stopping us to get a AC. So if I look at this specific thing, I was doing one thing. Okay, I had a I was going on to all the previous J's, and I realized that my maqsad, my main aim was that, okay, I was at I was going on to all the previous J's, and then I have to for sure incorporate my K. That is for sure. I will have to for sure incorporate my K. That's an extra condition which I have to verify. So I will have to take it. I is something I will have to go on to all the elements. So this thing seems for sure this will be there. I, which means n into k, will for sure be there. J, which means going on to all the previous indexes. Somehow I need to remove it. Now, if I take O of n to k, it will be roughly around 25 to 24. which will work. Again, I might also feel that I can also take a log n, which means along with this O of n to k, I can also take a log n also factor in consideration, which means I can maybe apply a segmentary kind of route also. I can think of that, but I know O of n into k and O of n to k log n both will work. Now let's start thinking that, but anyway whatsoever, my main aim was that I cannot afford to go on to all the previous indexes. Now if I look and tell you what you were doing earlier is, you again, I did not converted my top down to bottom up, because I will show you the code, like I'll show you this dry run itself. So this what I have written in pen, that's simply bottom up for the same code of top down which we have seen above. So you were doing one thing, you were at I, you were going on to all the previous j's. So you, for a specific I am telling, for specific I right now, you are going on to all the previous j's, right? And then if your nums of I was equal to nums of j, then you tell that, and you simply tell, like when you simply told Aryan that okay, your dp of I remaining k, because you are going to the same element, your remaining k will remain intact, and then you will try for all the possible j's previously. And then as you are adding a I onto the like previous length, previous maximum length, so you will simply add a +1, and you are maximizing it always. You remember, you are always maximizing your answer. You're always maximizing your answer, maximizing your answer. Now, to just represent the maximization, I have written the maximize. It represents this maximize represents maximum of this value and the other value. Now, this was when your I and j, when your nums of I and nums of j are same. When they are not same, then what you were doing, you were simply saying, okay, Aryan, for I and remaining k, I will go on to all the previous j's, and I will simply ask, as it is nums of I is not equal to nums of j, which means okay, it is different, so I have to reduce my remaining k, because I will use 1k for this making, for this subsequence making. So I will use 1k. So okay, my remaining k will reduce by 1. That's what you were doing earlier. This is the top down code of what you were doing earlier. Now, if I tell you what you were doing, you were writing dp of I remaining k, maximize your dp of j remaining k plus 1. I know that I cannot afford to go on to all the j's. So, and I also know that my nums of I is equal to nums of j. So instead, if I remove and say, okay, rather than index, I will say, okay, dp of nums of I and dp of nums of j. And I know nums of j is equal to nums of I. So I can also write it as dp of nums of I. So I will write as dp of nums of I remaining k. I will maximize my answer and say dp of nums of I remaining k plus 1. And I know I'm just maximizing it. So this will already be maximum. Okay, maximum of dp of nums of I remaining k, and just maximizing your answer. But you have a, like you might end up having a doubt, Aryan, you are, which means you are actually storing your nums of I in your dp, which means, Aryan, are you saying that you will initialize your dp state by nums of I, which is 1e9? I'll say not really, which means I will not initialize my dp by saying, okay, 1e9 and then k, which is again 50. I'll not say that. I'll rather say, I know the maximum distinct values of my nums of I can be 5000, because I itself is 5000. So the maximum number of different values in my dp can be 5000. So I can simply say 5000. But Aryan, if you initialize this value, how will you store a 1e8? Nums of I is 1e8. How will you store here? True. So what I will do is, I will not take a vector now. I will take an unordered map dp of saying 5000 as a length and 50 as a length again. 5000 will help me assign different 5000 values having any valuation as in amount, having any amount, having any nums of I can assign 5000 different nums of I values. So it's a reason I will initialize my dp by simply making it as an unordered map. But coming on back, that's a simple case, Aryan. That's a simple case. When nums of I, nums of j both are equal, then you simply thought of that I can assign that, and rather take a nums of I itself in consideration. because it's the same element. The issue is, what about the different element? When the nums of I is not equal to your nums of j, then what? Again, let's try it. So I will simply assign my dp of I remaining k will be dp of j remaining k minus 1, same, minus 1, and then plus 1. But here, if my I have assigned to nums of I now, which means, okay, at this place, I will now put a nums of I. I'm asking for all the j's where it is not equal to nums of I. So here I should actually go and try for all the values which are not equal to nums of I. But Aryan, still you will have to go and try for all the values which are not equal to which are not equal to which are not equal to nums of I, right? Yeah, that's true. But for that, again, like, it boils down to, you will have to go on to all the values which are not equal to nums of I, and that can be at max n minus 1. So what to do for this? Simply, bro, I am saying it is not equal to nums of I, right? This j, it is not equal to nums of I. What if I take nums of I also? Which means I am saying in this place of j, you are taking not equal to nums of I, take nums of I also. Then you will say, Aryan, but it is violating my this rule, right? Bro, if it is violating this rule, I am saying, even if you take this, even if you take the above rule, and even if I ask you dp of I remaining k, if I would have given you dp of I remaining k remaining k minus 1, then for sure dp of I remaining k is more than dp of I remaining k minus 1, right? So if I am taking this nums of I in consideration and saying that, bro, take nums of I also, again, I just want one thing. I cannot afford to go on to all the previous indexes. So, but this says go and try for all the values which are not equal to nums of I. But I want something holistic, so that I will take everything holistically. Just wait for a minute. Then what will happen? Okay, nums of I have also taken. I know that dp of nums of I remaining k minus 1 is already less than dp of nums of I remaining k. Make sure that one part, that's very important. dp of nums of I remaining k minus 1 is less than my dp of I remaining k. Thus I know one thing for sure, that incorporating it will not affect my dp of nums of I remaining k, right? It will not affect my answer. So I can now easily say that dp, again, just transforming the same condition, dp of nums of I remaining k is actually maximizing my dp of this value by dp of anything. Now this nums of j can be anything. It is not specifically needing to not equal to nums of I. It can be anything and then remaining k minus 1. So technically it says me that, bro, Aryan, give me the maximum for this remaining k minus 1, give me the maximum dp value what you can give me. So I should rather maintain for a specific remaining k what is the maximum dp value it can have. And thus, if I maintain this, I can just maintain one more vector saying maximum dp for a specific k, and I will pass in this remaining k. This will give me the maximum. So I can just replace the entire thing and can just replace it with this. Again, here the remaining k is remaining k minus 1, so just write remaining k minus 1. If I can replace this entire stuff by this one vector, and voila, you have solved a very big issue, because now you don't need to go on to all the other elements, because it is anything. And here also, in the first case, it is the same number. So this is the same number. So as it is, but this was a different number. But here we realized anything can come in. If anything can come in, I can put a new vector which will give me the maximum dp value for a remaining k. And thus now my answer became the first condition, and the second condition now became that dp of nums of I remaining k is maximizing my this value. This value is maximum for k, of maximum dp value for a k, and thus I will pass in remaining k minus 1 and then plus 1 for a new extra length added. And how will I update my remaining k? How will I update my maximum dp for k? I'll simply say maximum dp for k for the specific remaining k will be the same value of this dp value, because I just want to make sure that this vector maximum dp for k having for a remaining k should be just maximum dp value for the specific remaining k. So just maximize it with the maximum dp value. Okay, remaining k for all the dp values for all the i's. Just maximize this answer, this vector. Now let's see the code. It will be much more clear. So what we did? Firstly, we took an unordered map. It is very important to take an unordered map. You remembered why it is important? Because I want to take a nums of I now, not index. Now when this is taken, I know my other was remaining k, and then this will contain my maximum dp value. So it is a dp vector. Now when this is done, I will have one more vector which is maximum dp value for a specific k. Same I will maintain for a remaining k. I will go on to all the indexes. I will go on to all the k's. Your first doubt can be, Aryan, why is this remaining k sorted in the it is in the decreasing order? Why can't I start remaining k from 0 and go to the actual k? That's the first question which I will answer just a second. But considering you will try for both I and remaining k pairs, the same what we were doing in the top down approach, same thing. Just that what we make sure, okay, my dp of nums of I remaining k, I am maximizing with dp of nums of I remaining k plus 1, which is the first case, then second case, maximum dp value for a k for remaining k minus 1 and then plus 1. This was my second case. Now when this is done, make sure one thing, that if your remaining k is equal to 0, which means you cannot even afford to have any different element, because remaining k, it tells you if something you can have it as different or not. If the remaining k is 0, you can not afford to have something different. If you cannot, make sure you cannot incorporate something altogether. But Aryan, what about the nums of I part? Bro, you have already covered that here. Now, when this portion is done, you have got your dp value, but make sure you are using this maximum dp for k. So maximize it. So maximum dp for a k, for the current remaining k, I'll just maximize it. Maximize it, this value only, and then your remaining k dp value. This will help you to maximize my maximum dp value for a k. Now, why is this in this opposite order? This is because you will see you are actually accessing your remaining k minus 1. You're accessing your remaining k minus 1. So for a specific index, just take an example. For a specific index 1, which means, okay, for a specific index, the value is nums 1. For a 1, I should only take in consideration the previous value, because the j's were previous. But as I am building my dp of I remaining k, now I have separated out and I have said, okay, for all the j's, I will consider by saying maximum dp value for a k. So if I will go on as by saying, okay, remaining k equal to 0, remaining k equal to 1, remaining k equal to 2, and so on and so forth. If I go in this order, what I might end up doing is, for a specific remaining k as 2, I will go and access remaining k as 1. But as I am going in the order of my k, again, considering this entire thing is remaining k equal to 0, remaining k is less than equal to k, and remaining k plus plus. If this would have been the case, then you would have already maximized your remaining k, which is you would have already maximized your remaining, where is this gone? Yeah, you would have already maximized your remaining k as 1 when you were at this index I only. So at this index I, whatsoever remaining k as 1 would have been there, that would have been at the influence of I. So when I am at 2, I'm using a remaining k as 1, which is because of the influence of I. But I wanted only the influence of j's. That is the reason I have to make sure I go in the reverse order. And that's the reason we go in the reverse order, so that we don't influence our existing I for the result of dp of I itself. Cool. And when this is done, I can simply go on to all the remaining k's, because we know remaining k just maintains the answer for that specific k. So I can just maximize maximum length for all the possible k values and just get my answer. Cool. But I just tell you one more trick. You can also return your maximum dp value for k for a specific k, like k only. Why it is that the case? Because I know Because I told you already that while we were building this, we realized one thing, that we're always maximizing our remaining k, which means we told that dp of any nums of I and the corresponding remaining k minus 1, it is less than dp of same value and remaining k. That is the reason we know that this is always large than my previous one. That is the reason I know that I can simply return my dp of my maximum dp value for k of k itself, which means k, only k, and that you can also return as an answer. Cool. Thus the time for this is O of n into k, and space is actually again O of n to k. Why again time is O of n into k? Because you can see here O of n to k. Space is you will have nums of I distinct values can be at max 5000, which is n, and remaining k is k itself, and that is the time space property. Cool. I hope you guys got it. The problem was easy, the code is pretty easy, but understanding that time, understanding the reason and approaching it makes it tricky. Cool. I hope you guys got it. If yes, then 45k June. Yaad rakhna. Bye bye. Take care.